Number 1. The Sarcastic Fringehead. We begin where the sunlight still reaches in the shallow sandy flats off the coast of California. Here, in water only a few meters deep and reaching down to about 73 meters, lives a fish barely 30 centimeters long. For most of its life, it looks almost unremarkable, a slender, mottled brown creature tucked inside an empty snail shell or a discarded bottle. Its scientific name is Neoclinus blanchardi, and it belongs to a family of small tubelinies found from San Francisco south to the coast of Baja California. You could swim past it and never know it was there. Then something approaches its home and the fringehead transforms. Its entire head appears to split open. The jaws unfold outward into an enormous fan, a gaping umbrella of flesh ringed, in the males, by a glowing yellow-green membrane and studded with blue spots. Rows of small needle-sharp teeth line the edges. In an instant, a palm-sized fish becomes something that looks like it belongs in a nightmare. The name itself carries the warning. The word sarcastic comes from a Greek root meaning to tear flesh. What is this display for? The mainstream explanation, drawn from decades of aquarium observation, is territorial combat. When two males dispute the same shell, they press their wide-open mouths together, jaw against jaw, in a strange and violent kiss. The one with the larger mouth wins the contest and the home. Because mouth size scales with body size, that gaping display is an honest signal of strength. A second interpretation holds that the same show doubles as a courtship signal, a way for males to advertise their fitness to passing females who will lay clutches of up to 3,000 eggs inside a favored male shelter for him to guard. A third view treats the whole ritual as a broader dominance language, a way to settle disputes without ever drawing blood. To a diver, the fringehead is harmless, capable of nothing worse than a startling nip. It is a patient ambush hunter, darting out from its shell to grab passing small fish, squid eggs, and crustaceans before retreating back inside. Its mottled brown body blends perfectly into the shell rubble and sediment, so that most of the time it simply vanishes. This is a creature that tolerates the cool, shifting waters of the California upwelling, a fish of the everyday coast. Its fame is almost entirely modern. Footage from the Monterey Bay Aquarium and vivid photography that spread online around 2015 turned this obscure blenny into an internet sensation, precisely because of that alien, unfolding mouth. But it teaches us the rule of this entire descent. Here at the top, in the light, the terror is mostly theater. As we go deeper, it stops being a bluff. Number 2, the Atlantic Wolffish. Drop below the sunlit shallows onto the cold rocky shelves of the North Atlantic and the fear changes character. It is no longer a startling display. It is raw, crushing power. The Atlantic wolffish, Anarchias lupus, is known to fishermen by darker names, the sea wolf and the devilfish. It grows to about 1.5 meters long and can weigh close to 18 kilograms. A thick, eel-bodied fish with a blunt, scowling face found on both sides of the ocean, from Canada and New England across to Scandinavia and the British Isles. Look at its mouth and you understand the nickname. At the front of its jaws are prominent conical canine teeth like fangs that jut outward past the lips. Behind them sit rows of flat, crushing molars set both in the jaw and across the roof of the mouth. This is a machine built to destroy armor. The wolffish feeds on some of the hardest prey in the sea urchins bristling with spines, thick whelk shells, large hermit crabs, green crabs, and cockles. It simply crushes them. Those teeth wear down from the constant grinding, so the wolffish sheds and regrows them each year. It lives in genuinely hostile cold on rocky bottoms from 20 meters down to around 500, in water that can hover near 1 degree Celsius. To survive there, the wolffish manufactures its own antifreeze, special proteins in its blood that stop ice crystals from forming inside its body. This is the first of many chemical tricks we will meet, biology quietly rewriting itself to endure conditions that would kill us. Its private life is stranger still. Unlike most fish, which scatter eggs and sperm into open water, wolffish pair off and fertilize internally. The female lays a cluster of unusually large eggs and the male stands guard over the nest for months, driving off anything that comes near. Scientists value the wolffish as a keystone predator that keeps urchin and green crab numbers in check, protecting kelp forests and shellfish beds. It is a reclusive animal, denning in rocky crevices and emerging to forage, and it lacks pelvic fins entirely, swimming with a slow, eel-like undulation along the bottom. It has close relatives, the spotted wolffish and the northern wolffish, that share the same cold northern seas. Its antifreeze biochemistry has become a genuine subject of research, a natural model for how living tissue might be protected against freezing. Slow-growing and late maturing, it is easily harmed by trawling, and yet it is fished and sold under gentler names like ocean catfish and loup de mer, demand that has pushed its numbers down. In United States waters, it is now formally a species of concern. Its teeth were built to crush. But deeper down, in the fading light, creatures learned to hunt with something stranger than force. Number 3, the Dumbo Octopus squid. Now the sunlight begins to die. Between roughly 200 and 1,000 meters lies the twilight zone, where the last blue glimmer of the surface fades to black. This is the hunting ground of Taenia dani, the Dumbo Octopus squid, named for the Danish biologist Åge Vedel Tonning, and the research vessel Dana. It is one of the largest squid in the ocean, with a mantle reaching about 1.7 meters and a weight near 60 to 70 kilograms. What makes it terrifying is not its size. It is what it does with light. At the tips of 2 of its arms sit the largest light-producing organs known in any animal on Earth, each about the size of a lemon. These organs have lid-like structures that snap open and shut, so the squid can fire its light in sudden blinding flashes rather than a steady glow. In 2005, a Japanese team led by the researcher Tsunemi Kubodera filmed this animal hunting in the wild off the Ogasawara Islands, one of the first times such behavior had ever been recorded. The footage was extraordinary. Just before striking its target, the squid blazed its arm lights into the darkness. Scientists believe the flash serves as a weapon. It may blind and disorient prey in the instant before the attack, and it may help the squid judge the exact distance to its victim, like a photographer's flash freezing a moment. Unlike most squid, the adult Dumbo Octopus squid has no long feeding tentacles at all. Instead, it seizes prey with 8 muscular arms, armed not with suckers but with hooks that leave distinctive scars on whatever they touch. Curiously, the juveniles do have tentacles which they lose as they mature. There are competing readings of the light. The mainstream view, built on that rare footage, is that the flash is offensive, a tool for the hunt. Others suggest it may startle predators, buying an escape, or serve as a courtship display in the lightless dark. We know the squid itself is hunted because its beaks turn up regularly in the stomachs of sperm whales diving through these depths. Its large eyes are tuned to detect the faint bioluminescence of the twilight zone, and it is a surprisingly strong and agile swimmer propelled by fins that span much of its mantle. It is not fished by people, but it sits at the center of the deep food web as both a fierce predator and a meal for the largest toothed whales. There are even accounts of it lunging aggressively at submersibles and cameras, adding to its menacing reputation. The wolffish killed with force, this animal kills with light. But some hunters, deeper still, need no light at all. Number 4. The prickly shark. Below 1,000 meters, the last of the sunlight is gone completely. From here down, the only light is the light that living things make for themselves. And here we meet the first shark of our descent, an animal so rarely seen that most people have never heard its name. This is the prickly shark Echinorenus cooki, a stout, heavy-bodied fish that can reach about 4 meters in length, lurking along the outer continental slopes and inside the deep submarine canyons of the Pacific. Run a hand along its body, and you would understand the name at once. The prickly shark is covered head to tail in coarse, thorn-like denticles, giving its skin the texture of rough sandpaper studded with spikes. It is a sluggish, slow-moving animal, and that slowness is the point. In places like Monterey Canyon off California, submersibles have found prickly sharks hanging almost motionless in the water column, suspended in the dark like something waiting. When prey drifts close, the shark lunges and uses suction, its large mouth expanding to swallow fish, other sharks, egg cases, and squid whole. Almost everything we know about it comes from chance encounters with deep-diving robots. The research institute MBRE, based on Monterey Bay, has captured much of the limited footage that exists, glimpses of an animal that spends its life beyond the reach of human divers. Its 2 dorsal fins sit far back near the tail. It has no anal fin at all, and its broad, flattened head carries eyes without the protective third eyelid that many sharks possess. For all its fearsome appearance, the prickly shark is harmless to us simply because it lives where we almost never go. There is much we cannot explain. We do not fully understand why the sharks gather in canyons, whether the aggregations are about feeding, breeding, or something else entirely. We know it gives birth to live young, and that its litters may exceed 100 pups, among the largest broods of any shark. It has a cousin, the bramble shark, that fills the same role in the Atlantic and Indian Oceans. Beyond that, its biology is a near blank. We know almost nothing certain about its lifespan, its growth rate, or its migrations, because it is encountered so rarely. Its slow metabolism suits the cold, low-energy world of the deep slope, and it occasionally turns up as accidental bycatch in deep-water fisheries, where it has little commercial value. Its denticles are so distinctive that even a fragment of skin is enough to identify the species. The prickly shark is armored and patient, but below it lurks a predator older than the dinosaurs. Number 5, the Bluntnose six-gill shark. Descend further and you meet a creature that has barely changed in hundreds of millions of years. The Bluntnose six-gill shark Hexanchus griseus is a living fossil. Its very anatomy marks it as ancient. Almost every modern shark has 5 gill slits on each side. This one has 6. That single extra pair is a signature of a lineage, the Hexangiformes, that stretches back to the age of the earliest dinosaurs, with a body plan that closely matches fossil sharks from the Triassic and Jurassic periods. It is also enormous. A full-grown six-gill can exceed 5 meters in length and weigh more than 400 kilograms, making it one of the largest sharks in the sea. It ranges through deep temperate and tropical waters worldwide down to at least 2,500 meters. But it does not simply stay in the depths. Each night the six-gill rises, climbing towards shallower water under cover of darkness to hunt, then sinking back into the black by day, a daily migration through thousands of meters of water. Its eyes glow an eerie green, reflecting light through a mirror-like layer called the tapetum lucidum that lets it gather every scrap of illumination in the gloom. Its lower teeth are unlike a great white's simple triangles. They are broad and comb-like, almost saw-shaped, designed to saw chunks from prey too large to swallow whole. And it eats almost anything: fish, rays, other sharks, squid, crabs, and the sunken carcasses of larger animals. Studying it is brutally hard. In 2019, a research team aboard the Oceanic submersible managed something never done before, tagging a blunt-nosed six-gill directly at depth rather than dragging it to the surface, a genuine milestone in deep-sea science. There is real debate about the animal. Some researchers emphasize its role as an active predator, others as a patient scavenger, and no one fully understands why it has clung to 6 gills when the rest of the shark world moved to 5. It is slow-growing and late to mature, taking what may be decades to reach breeding age, which makes it fragile despite its size, and it is now listed as near-threatened. Though generally sluggish, it is capable of sudden bursts of speed when feeding. At a few unusual sites, such as Puget Sound, six-gills venture into shallow enough water that divers occasionally meet them face-to-face, a rare chance to see an animal that normally lives beyond reach. And like so many deep predators, it scavenges the carcasses of whales that sink to the seafloor, linking it to the vast recycling system of the deep. Older and larger still, something glides even deeper. Number 6, the Pacific sleeper shark. The deeper we go, the quieter the ocean becomes, and the Pacific sleeper shark is silence made flesh. Somniosus pacificus is a close relative of the famous Greenland shark, and it haunts the cold depths of the North Pacific from Japan and the Bering Sea down to California, and deeper still in warmer latitudes. It may exceed 4 meters in length, and there are persistent, unverified reports of individuals far larger, rivaling the great white shark. Yet almost no one has ever seen one alive. Its very name tells the story. The genus Somniosus means sleepy, a nod to the way it moves. The sleeper shark swims with almost no visible motion of its tail, gliding through the black water like a slow gray ghost. That silence is a weapon. Prey never hears it coming. Its stomach contents reveal an unsettling range of victims: fast-moving giant Pacific octopus, fish, squid, and traces of seals and even whales, whether hunted or scavenged from carcasses on the seafloor. Everything about it is built for the cold, food-poor deep. Its metabolism is extraordinarily slow, and like the Greenland shark, which can live for centuries, the Pacific sleeper is thought to be remarkably long-lived, though it has been studied far less. Its flesh is laced with a compound called trimethylamine oxide, which makes it toxic to eat, a chemical we will meet again at the very bottom of this journey. Its eyes are often infested by a parasitic copepod named Omatocoiti that dangles from the eyeball and can leave the shark half blind, though in perpetual darkness, sight matters little. It hunts instead by smell and by sensing the faint electrical fields of living things. Live footage is almost non-existent. In 2019, a NOAA remotely operated vehicle in the Gulf of Mexico captured a large sleeper shark moving in on a baitfall before it was jostled aside by others crowding the food. Its body is soft and heavy, built for slow, tireless cruising rather than speed, and many researchers suspect it plays a significant but badly underappreciated role as an apex scavenger and predator across the deep Pacific. Like the Sixgill, it gathers at whale falls, helping to dismantle the largest carcasses in the sea. The great open questions remain. We do not know how large they truly grow. We do not know how long they live. An animal that may be bigger than a great white drifts through the deep Pacific, and we have barely glimpsed it. Yet even this giant must yield the deepest water to a shark that glows. Number 7. The Portuguese Dogfish. At around 3,700 meters, we reach the deepest confirmed limit of any shark on Earth, and the animal that lives there carries its own light. The Portuguese dogfish, Centrosymnus colalipis, is small, only about 1.2 meters long, and robust, built to withstand a world that would crush most life. It cruises the abyssal slopes of the Atlantic, first studied off the coast of Portugal, as well as the Mediterranean, Pacific, and Indian Oceans. Its eyes are large and reflect a faint green, adapted to gather the almost non-existent light of the deep. But its most remarkable feature is hidden on its belly. The Portuguese dogfish is covered, particularly on its underside, in photophores, tiny organs that produce a soft glow. This might seem to make no sense. Why would an animal hiding in darkness light itself up? The answer is one of the ocean's most elegant tricks called counter-illumination. Seen from below against the faint light filtering from far above, a dark shark would appear as a black silhouette to any predator lurking beneath it. By glowing gently on its underside, the dogfish erases that silhouette, blending its belly into the dim glow overhead and effectively becoming invisible. Researchers, including Julian Cleese and Jérôme Malafay, have documented this deep sea glow in detail. To live this deep, the dogfish has solved problems of buoyancy and pressure. It has no swim bladder. Instead, it carries a large liver filled with light oil that keeps it from sinking. That same liver, rich in a substance called squalene, has made it a target for deep water fisheries. And combined with its slow reproduction, only about a dozen pups per litter, it is now considered near threatened. Its skin is smooth with overlapping denticles that reduce drag as it glides, and its eyes are specially adapted to squeeze the most information from the faintest scraps of bioluminescent light. Unlike the Sixgill, which climbs and dives thousands of meters every day, the Portuguese dogfish keeps to the deep, making only limited vertical movements, a true resident of the abyssal slope. There are competing ideas about the glow. The mainstream view is camouflage, the erasing of the silhouette. Others suggest the light also serves for communication between individuals in the dark or for luring prey. What the Portuguese dogfish makes clear is a turning point in our descent. This is where even the sharks, the ocean's classic predators, reach their limit and surrender the deepest zones to stranger life. Number 8. The Abyssal Grenadier. Now we cross onto the abyssal plain itself, the vast flat muddy floor of the deep ocean that covers more of the planet than all the continents combined. It stretches from about 2,000 meters down to 6,000, a freezing, lightless desert. And the undisputed ruler of this desert is a fish most people have never heard of, the grenadier, also called the rat-tail. The abyssal grenadier, often identified as Coryphaeanischides armatus, belongs to a family, the Macrouridae, that is one of the most abundant on Earth, with hundreds of species making up an enormous share of all deep-sea fish. You would know it by its shape. It has a large bulbous head with big eyes and enormous nostrils, and a body that tapers away into a long, thin, whip-like tail, exactly like the tail of a rat. It has no proper tail fin. The body simply narrows to a point, an efficient design for cruising slowly and endlessly across the mud in search of food. And here the fear becomes something new. It is not a single monster. It is the swarm. When anything dies and sinks to the abyssal floor, the grenadiers find it. Scientists study this with baited camera landers, weighted platforms dropped to the seabed with bait and a camera attached. Researchers at the University of Aberdeen's Ocean Lab have shown that within hours of a carcass hitting the bottom, grenadiers converge from across the dark, drawn by an acute sense of smell so powerful it can detect death across vast distances. Dozens of pale, big-eyed rat tails materialize out of the blackness to strip the body clean. They are the cleanup crew of the deep, recycling the nutrients that rain down from far above, and they help dismantle even whale falls, the enormous carcasses that feed the seafloor for years. Many carry light organs filled with glowing bacteria, and some can drum sound with their swim bladders to communicate. Their large eyes are thought to detect the faint bioluminescence of prey and rivals in the dark. Their flesh is watery and low in energy, an adaptation to a world where food is rare and every calorie counts. They grow slowly and live for decades, which is exactly why they have become a key study organism for scientists trying to understand how the deep sea is fed. Certain species, like the round-nosed grenadier, are now trawled by deep water fisheries, raising real concerns about how quickly such long-lived fish can recover. Past the scavengers, at the very edge of where the abyssal plain gives way to the trenches, the octopus lineage reaches its own astonishing limit. Number 9. The Dumbo Octopus. Some creatures are frightening because they look like monsters. The Dumbo Octopus is unsettling for the opposite reason. It looks gentle, almost sweet, and it lives deeper than any octopus has any right to. These animals belong to the genus Grimpoteuthis, and they take their nickname from the two large ear-like fins on top of their bodies, which flap as they move and recall the flying elephant from the old Disney film. They are the deepest living octopuses ever found. A study published in 2020 involving the deep-sea researcher Alan Jameson documented Dumbo octopuses at a depth of nearly 6,957 meters, far below where any other octopus has been seen. Most are small, only 20 to 30 centimeters across, though some reach nearly 1.8 meters. They do not jet through the water like shallow octopuses. Instead, they drift, flapping those ear-like fins and gently pulsing the web of skin that connects their arms. That web is a tool. It folds into an umbrella or a bell, and with it, the Dumbo octopus engulfs its prey and swallows it whole. Worms, crustaceans, and small invertebrates plucked from the seafloor. It does not bite and tear the way a familiar octopus does. It has abandoned things it no longer needs. It has no ink sac, because a cloud of ink would be pointless in a world with no light for it to hide in. Its body is soft and gelatinous, without the rigid structures that immense pressure would damage, letting it survive where the water would crush a submarine. Females carry eggs at many different stages of development at once and can store sperm so they can reproduce whenever the harsh conditions allow. We know so little about them. Even the formal descriptions of the different species remain incomplete, and nearly everything we have seen comes from a handful of deep-diving robots and submersibles. It lives a hovering, benthopelagic life, drifting just above the seafloor across Abyssal and Hadal depths. And because it lives so deep, it has almost no predators, only the occasional deep-diving fish or shark. Its large eyes can do little in the dark, so it feels its way through the world by touch and by chemistry. The gentle drifting shape hides a predator that swallows life whole. And below even this, in the crushing trenches, lives the deepest fish ever pulled from the sea. Number 10. Abyssobrotula Galatheae. We have reached the bottom of the ladder, the Hadal zone, the deep ocean trenches that plunge below 6,000 meters into the darkest, most crushing places on the planet. And here lives the record holder, the deepest fish ever collected, a small, pale cusk eel named Abyssobrotula Galatheae. It was hauled from a depth of 8,370 meters in the Puerto Rico Trench, the deepest point in the entire Atlantic Ocean. Its name honors the Danish Galatheae expedition that brought it up from the dark. You might expect the deepest fish on Earth to be a giant. It is the opposite. Abyssobrotula Galatheae is only about 16 to 20 centimeters long, slender and eel-like, with pale, soft flesh and almost no scales. It is blind, or very nearly so. Its eyes are shrunken and reduced because at this depth there has been no light for it to see for millions of years. It navigates and hunts entirely by other senses, feeling the faint movements of the water through its lateral line, and tasting the chemistry of the mud, picking off tiny amphipods and other invertebrates on the trench floor. The pressure where it was found defies imagination. At 8,370 meters, the weight of the water above presses down at more than 800 times the pressure at the surface, enough to implode a conventional submarine. That this fish lives there at all pushes against the known limits of vertebrate biology. Scientists studying the deepest fish have found something remarkable. There may be a hard ceiling, somewhere around 8,200 to 8,400 meters, below which no fish can survive. The reason lies in a single molecule, that same trimethylamine oxide we met in the sleeper shark. It stabilizes proteins against the deforming force of extreme pressure, and the deeper a fish lives, the more of it the fish needs. At around 8,400 meters, a fish would need so much that its body chemistry would simply break down. There is a wrinkle worth noting. The record specimen was actually recovered dead as it was being hauled up, so some scientists debate whether the fish was truly living at the full 8,370 meters or was caught as the gear passed through shallower water. Either way, the capture depth set the record. The cusk eels of its family, the Ophidiidae, are found throughout the world's oceans, but Abyssobrotula is specialized for the extreme deep, and its discovery genuinely reshaped how far down scientists believed vertebrate life could persist. Almost nothing is known of its behavior, its lifespan, or how it reproduces because sampling the Hadal trenches is so punishingly difficult. Living snailfish now hold the record for the deepest fish ever filmed alive, but Abyssobrotula holds the deepest verified capture, and it marks the place where life itself begins to run out of room. This is where the terror ladder ends, not with a monster, but with the crushing dark and the edge of what is possible. Look back up the way we have come, and a pattern emerges. The creatures did not simply get bigger or toothier as we descended, they got stranger, more alien, further from anything we recognize. And there is a reason the fear grows with the depth. It tracks the loss of the one thing our whole world depends on, sunlight. In the sunlit surface, life looks familiar. In the twilight zone, where the light fades between 200 and 1,000 meters, animals like the Dumbo Octopus squid begin making their own light to hunt. Below that, in perpetual black, the Portuguese dogfish and the grenadier carry glowing organs of their own because in the absence of the sun, light becomes something you manufacture. Pressure climbs relentlessly, roughly 1 atmosphere for every 10 meters, until in the Hadal trenches, it exceeds 800 times what we feel at the surface. Food grows desperately scarce, which is why the deep favors patient scavengers, slow metabolisms, and animals like the Dumbo Octopus that swallow whatever they find whole. Cold near the freezing point forces chemical solutions like the wolffish's antifreeze. What we read as horror is really unfamiliarity. These are bodies solving problems we never have to face in a world so unlike our own that our instincts simply read it as wrong. The creatures of this descent seem wildly different, yet they draw on a shared toolkit, a set of solutions the deep sea invents again and again. Understanding those tools makes the whole journey click into focus. The first tool is light, from the flashing photophores of the Dumbo Octopus squid to the bacterial light organs of the grenadier and the belly glow of the Portuguese dogfish. Bioluminescence is the currency of the dark, used to hunt, to hide, and to signal. The second tool is pressure-proof chemistry, above all trimethylamine oxide, the molecule that shields proteins from being deformed by crushing depth, and which ultimately sets the limit on how deep a fish can go. The third tool is buoyancy, without a swim bladder, solved by the Portuguese dogfish with its oil-filled liver. The fourth is antifreeze, the special proteins that keep the wolffish from freezing. solid in near icy water. Then come the sensory shifts, the huge nostrils of the grenadier, the electrical sense of the sleeper shark, and the lateral line of the blind Abyssobrotula, all replacing eyes that no longer help. And there are the reproductive strategies, egg guarding, live birth, and sperm storage, each a way to keep a lineage going where life is thin. Each creature's kit maps neatly onto its depth. For most of human history, all of this was invisible. We knew the deep sea held life only from the broken, half-rotted specimens that dredges dragged to the surface. The animals of this journey became real to us only through a revolution in technology, and each one has its own story of discovery. The scavengers of the abyssal plain revealed themselves through baited camera landers. Weighted rigs dropped to the seafloor that filmed grenadiers swarming out of the dark, pioneered by teams like the Aberdeen Ocean Lab. Remotely operated vehicles and submersibles, especially those run by the Institute MBRI in Monterey Canyon, gave us our rare glimpses of the prickly shark hanging motionless in the water. In 2005, Tsunemi Kubodera's team captured the Dana octopus squid attacking with its lights. In 2019, the Ocean X submersible tagged a bluntnose sixgill at depth, and a NOAA robot filmed a Pacific sleeper shark at a bait fall. The deepest discoveries needed Hadal landers built to survive the trenches, machines that documented Dumbo octopuses near 7 kilometers down, and recorded fish at the very bottom of the world. And the record holder, Abyssobrotula, came up long ago aboard the Galatheae expedition. Yet for every creature we have filmed alive, countless others have never been seen moving at all. For all we have learned, the deep ocean remains the least explored place on Earth. And every animal in this descent trails unanswered questions behind it. We have mapped the surface of Mars in more detail than we have mapped our own seafloor. We do not know how large a Pacific sleeper shark can truly grow, whether those reports of monsters rivaling the great white are exaggeration or fact. We do not know what waits in the deepest trenches we have never sampled, whether some fish or creature breaks the barrier that biology seems to set. The behavior, the lifespan, and the reproduction of Abyssobrotula are essentially a blank page. Even the Dumbo octopuses have not all been properly named and described. We cannot explain why prickly sharks gather in their canyons, and our estimates of how much life the deep actually holds are still rough guesses. The honest truth is that we've explored only a tiny fraction of the deep sea in any real detail. Each expedition that descends comes back with something no one predicted, which means the 10 creatures of this journey are almost certainly not the strangest down there. They are only the ones we have managed to find. The journey we have taken is a descent from the familiar into the utterly alien. At the top, in the light, a small fish frightens us with a bluff, a mouth thrown open in a display it cannot really back up. At the bottom, in the crushing dark, a blind palm-sized cusk eel sits at the edge of what life can physically endure, asking nothing of us and barely aware we exist. Every rung of that ladder is a different answer to the same set of problems: darkness, cold, pressure, and hunger. The bioluminescence, the antifreeze, the oil-filled livers, the pressure-proof chemistry, these are not horrors. They are triumphs. Evolution reaching into the harshest place on the planet and finding a way to live there anyway. What we call terrifying is often just extraordinary seen from the wrong angle. The deep sea is the largest living space on Earth, and we have seen almost none of it. Our machines are only beginning to reach the bottom, and every time they do, the ocean hands back something we did not expect. So the next time you picture the sea, do not stop at the sunlit surface. Think of the ladder going down, zone by zone, past the sharks, and the swarms, and the drifting ghosts, all the way to the trench floor, where the pressure never lets up and the dark never ends. And know that it is still down there, waiting to be seen.